All right, we're going to go through two more examples of the nonlinear systems. So again, these are the 3 variables, 3 equation. This is example 5. So tell me, one, what's different about this one? There's 2 of them that are missing a variable, right? In 2, there's no x, and in 3, there's no y. So how you approach this might look completely different depending on how you did it. If you were to, let's say, just like thinking ahead, if I were to put 1 with 3, it's going to eliminate the x, right? So if I were to do 1 and 3, I'm going to eliminate the x, and that equation would have a y and a z. I could then use that with 2 without having to make another new one, as long as I involve all 3 of them. Does that make sense? Okay. Question. So how many of you did that? How many of you did 1 with 3? What did you do instead? 1 and 2? Okay. And canceled the y. Okay. So 1 and 2. Which one did you multiply by the negative? 2. Okay, so we're going to do negative 1 times 2. So 1 is x plus y minus 3z equals negative 1. And 2 would have been negative y plus z equals 0. This is x. The y's cancel. Minus 2z equals negative 1. And that's new 1. Okay, then you have to use 3, which is negative x plus 2y equals 1. And you have to cancel the same thing. So I have to cancel the y. Which one did you use then?
My 3 is different. It says that it's equal to 2.
Did you get fractions?
Yeah, I got fractions.
I probably changed it on purpose.
No, there's no solution.
I got no solution. I got no solution.
I did not get a fraction.
Oh, this one was no solution. Yeah,
I got a fraction.
this one should have been no solution. All right, we're going to go with what's here because I don't know why I changed it, but I'm sure I changed it for a reason. All right, so if you went from here, well, let me do the one that's on yours. It says equals 2 on the bottom?
Yeah.
That's what this one says? Okay, so this is 2. So now, which one did you pair it with?
1.
1, and you changed which, like, did you multiply by negative 2?
Yeah.
Okay. So negative 2. So negative 2 times the first one. And this is negative 2 times x. And negative 2 times y. And negative 2 times negative 3z, which is positive 6z. And negative 2 times negative 1, which is 2. And then you combine from here. Negative 3x. These cancel. Plus 6z equals 4. And that's new 2. Yep. Did you use those 2? Then you're going to get a different new 2. Yeah, you can get a different new 2 as long as, but the end answer should still be the same. All right, so now I have x minus 2z equals negative 1, and I have negative 3x plus 6z equals 4. Did you multiply the first one by 3?
Yes.
Okay. So then 3x minus 6z equals negative 3, and it cancels, and I get 0 equals 1. So no matter which path you chose, at some point you should have gotten a statement like that, and a statement like that means no solution. So your path might look very different, but as long as it cancels and gives you a false statement, it's no solution. I think I changed it because this would have been an example of an all real number. So if it had canceled and given you a 0 there, a 0 equals 0, then it would be all real numbers, okay? All right, so if you plan it correctly, you could do a lot less work on this one, okay? Doesn't mean you have to do it this way. But if you look ahead, you've got 2 equations with 2 variables, right? So if I had taken, let's say I take 1 and 3 together, I could cancel out one of those variables, right? And I could make it go down to just 2 variables. If those 2 variables would be the same as my 2, then I can use those 2 with 2, okay? Same goes for any other combination. If I did 1 and 3 together and I could cancel out a variable, I can actually narrow it down to 2 variables. And in that case, like if I canceled the z's here, I'd end up with an x and a y, and then that matches what's in the third one, and I could use the new one I got from 1 and 2 with 3, okay? If you didn't do it, you didn't catch it, it's not a big deal, but it is something that if you wanted to try, you could definitely try. So I'm going to work it through that way, just assuming that we did it, okay? But if you didn't, it's okay too. Remember, there's different ways to do these. So if I do 1 with 2 and I get x plus y minus 3z equals -1 and y minus z equals 0, my goal would be to cancel out based on 3, the z. It would be easy to cancel the y, but I could also cancel the z, and I'd get x plus y minus 3z equals -1, and then -3y plus 3z equals 0. And I get x minus 2y, these cancel, equals -1. And that's new 1. If I then use that with the only one I didn't use the first time, which is 3, I already have that narrowed down to the same 2 variables. If that didn't work, I would then have to use 3 with something else and narrow it down. But this time it's already the same. What happens when you combine these? Everything cancels. I end up with 0 equals 0 across the board, which is a true statement, yes? So no matter in which order you did it, at some point in your building, they should have canceled and you get a true statement. And in that case, this isn't all real numbers. If it was a false statement, then it would be no solution.
So you could cancel out just from like your new ones?
Because the new one used 2 and the third one was not in it, you'd have to use all 3. So you have to involve all 3 at some point. I can't cancel my new one with one of the ones I used,
Yeah.
but you can with the third one you didn't use.
Oh.
Yep. All right, so then this, the last one, this is 1, 2, 3. So give me one way to start. 2 and 3 in canceling? Good. All right, so 2 and 3, x plus 3y minus 2z equals -3, and 3x plus 2y plus 2z equals 6. And I get 4x plus 5y, these cancel, equals 3, and that's new 1. Then you used 1. Did you use 1 with 2? And multiply by 2? So I'm going to multiply 2 times 1, because I have to cancel out the z's. 2x minus 2y plus 2z equals 8. And then I'm going to use it with 2, because the signs are already opposite. X plus 3y minus 2z equals -3. 3x plus y equals 5. New 2. Then I got to use new 1 and new 2. Okay, how would I cancel out the y? -5 times the second one. So -15x minus 5y equals -25. And I get -11x equals -22. And x equals 2. Then where do I plug that back in? One of the new ones, right? So which one did you do? The bottom one? Okay. So 3 times 2 plus y equals 5. 6 plus y equals 5. And y equals -1. And then where do I plug those into? Good. One of the original ones. So which one did you pick? The top? So x is 2. Y is -1. Plus z equals 4. This becomes plus 3 plus z equals 4. And z equals 1. 2, -1, 1. Questions? Yep.
I had a question on the website.
Oh, okay. Oh, I. So you're going to tell me exactly what you did.
I got the other two numbers correct. I got all of them except when I got to the last one.
Okay, so which ones did you get first?
First I got x, which is 1, -1/2.
Yeah.
And then I got y, which is 1.
Okay, so then you plugged it in where?
I plugged it into the 2.
Okay, so 5 times -1/2 minus 2 times 1 plus 3z equals 0.
Yes.
Then you get -5/2 minus 2 plus 3z equals 0.
Yeah.
What'd you do from here? Get rid of the fraction or change the denominators?
Then I added it to 4/2.
Okay, so you made this 4/2, so -9/2 plus 3z.
And then I moved it to the other side.
And then added 9/2 to the other side.
And then I divided 3.
Okay. which is like multiplying by a third.
Yeah, don't you flip it?
No,
You don't flip it?
you did flip it.
Why is this one a
So by multiplying by a third, you are flipping it.
Oh, that's what I did.
Okay, that was an easy fix.
I got the first one right, but then I got -8, and then I got -3.
Okay, but I don't know what, so we have to go from the beginning then, because I have to figure out your new ones. So what'd you do first?
I put
You guys, shh. What?
1 and 3.
1 and 3?
Yeah.
Okay. Then what?
And then
Did you do the y's?
multiplied by -5. Yeah, I did the y. Two of the same column.
Okay. Is that a new one? 32x minus 10z equals 0.
No, it's a 1 and 3. Wait, did I say 2?
Oh, this is the one. Sorry, I didn't write it. That's a 1, so that's a 1. Okay. Then what'd you do after that?
2.
So you had to use 2, right? Yeah. And you did it with 3 multiplying by a -2?
Yeah.
So negative 9x minus 3z equals 0. Okay. Then what'd you cancel?
The 0.
So 10 and, which one did you make negative?
The top one.
Oh.
Oh, that's what I did wrong. I put a -3 instead of a 0.
Oh wait, this is still 1. Sorry, I wrote it wrong again. Yeah, no, that's right, because that should be 0. I mean, that should have been, I wrote the 0 instead of the 1. That should have been 1. So 6x equals -3.
Yeah.
Okay, so you got that one right. Then you plug it into what?
The
The 32x or the 9x?
Oh, I didn't plug in the negative when I put that.
It is always the negative. So be so careful. Yeah, usually, like if you know what you're doing and you didn't get it right, it's because of a negative somewhere along the line.
I put +1.
Just be really careful. From 9-2. So it, I would have multiplied everything by 12 to get rid of the denominators. So I'd do 12 on each step. 4 goes into 12 3 times and then distribute 3x plus 21. 3 goes into 12 4 times. 4y minus 4. Sure. 1 times 12, 12. So you combine it at 3x plus 4y plus 17 equals 12, and then subtract the 17. So that's in the same format. 4y equals -5. And then combine that with 2x minus y equals 15. So you could have multiplied the bottom by 4. Probably is the easiest.
Yeah, no, I got the rest.
Okay. Yeah, I would get rid of the fractions from the beginning, just like we did with the decimals. Get rid of them from the beginning. All right, so this says the total of 26,000 is invested in 2 corporate bonds paying 3.5 and 5%. So if my X is the 3.5 and the Y is the 5, you guys, shh. The investor wants an annual interest income of $1,000 from the investments. What amount should be invested at the 3.5? So because they only want one answer, I want to use that like strategically when I cancel out my variable. I don't want to cancel out the X because then I get Y equals and then I got to plug it back in. So first is that the two of them would add up to 26,000. And the second is that 0.035x plus 0.05y equals the amount they want, which is 1,000.
Wait, it's not 0, 0 plus 5?
No, because you're moving the decimal 2 places to the left. right? 5 is 5 with the decimal after it. You're moving the decimal 2 places to the left. So there's only 1 0 in front.
Oh, I see.
Yeah. Okay, to get rid of the decimals, I have to move it 3 places to get rid of the 1 on the 35. And that's 1,000. So 35x plus, this would go 1, 2, 3, which means 50y equals 1,000, and then add on 1, 2, 3 zeros. So it becomes 1,000,000. And then x plus y equals 26,000. So what I would do, we did these with substitution, and you still can. You can do substitution, but a lot of people choose elimination at this point, which I would probably have chosen elimination. But I want to eliminate the y, not the x. So I'm going to multiply everything by negative 50. Yeah. So I've got 1, 2, 3, 4 zeros, and then 26 times 5, 130. Yep.
Would you able to use a normal, like a non-graphing calculator?
Still up for debate. Yeah. Okay, and then this would be with 35x plus 50y equals 1,000,000. So the y's are going to cancel. I get negative 15x equals, was one of those negative? Yes, this should be negative. 1.3 minus 1,000,000. One, two, three, four, five. Nope, I had one too many zeros. Sorry. And that's negative. And then when you divide by the negative 15, you get 2,000. 20,000. Questions? So I would say any kind of word problem would be fair game. We did interest, but you could get another system kind. Okay, that's the application part. And pay attention to the questions, because if it said solve for both, I'd end up solving for x and y, but this one only said solve for the 3.5. So you would want to make sure that you're canceling out the one that you made the 5%, not the 3.5.
We get half credit.
If you what? All right, so 10.2 is called operations with matrices. 10.1 is actually solving systems of equations using matrices, which is joy. It's just pure joy. It's not. But you're going to do that in pre-calc. We're going to save that for that, okay? We wanted you to get to exposed to matrices. These matrices are on standardized tests, okay, because it's part of Algebra 2. But they usually don't, obviously if it's a system of equation, they're not going to force you to solve it because they don't know what method you're using. So you already know how to, that's the reason why we picked 10.2 over 10.1. You already know how to solve a system using all the other methods. So you could use a different method if it just said to solve the system, okay? But then there are other operations that we're going to do with matrices that don't involve solving systems. So we're talking adding, subtracting, and multiplying using matrices, okay? Matrices, which if you've ever seen the word, like the movie The Matrix, and it's filled with all those numbers, right? Rows and rows of numbers. It kind of looks like that. But it is defined as a rectangular array of numbers with m number of rows and n number of columns, okay? So it looks like that box that's there. You get brackets on the outside, and then you'll have a series of rows and columns of numbers. It can have however many rows and however many columns you want, okay? Rows go left to right. So this is a row, this is a row, this is a row. If I was to determine the order of the matrix, it's also called the dimensions of the matrix. Then I count the number of rows. There would be 3 here. I put the little X just like it's a 3 by, like you're reading like it's a 2 by 4, okay? It's like a measurement. 3 by the number of columns, and columns, if you think about a column holding up a building, go up and down. So the number of columns here would be 2. There is no rule on how many there has to be. There could be one of each. It could be a 1 by 1. It could be a 1 by 2. It could be a 1 by 12, okay? The order of them does not matter. There are certain times when the order matters, but when you're actually just given a matrix, there's no limit to how many rows or columns it can have. We are going to learn first how to add and subtract matrices. To do this, the matrices have to have the same dimensions. So you can only add a 2 by 2 to a 2 by 2. You can only add a 2 by 3 to a 2 by 3. They don't have to have the same number of rows and columns. It could be a 2 by 3 and a 2 by 3, but they have to match up with the other matrix. And then you'll literally just add and subtract the corresponding answers. So your answer, or your corresponding entries, which is like each spot. Your answer will have the same dimensions as your original matrix. So they could look like this. There's going to be two different formats. One is they literally just give you the matrix with your operation symbol in between. So for one, before you even start adding, make sure you can continue to do all of them. So this first one, what's the dimensions there? 2 by 2. The second one, 2 by 2. These can be added because they have the same. And now we just add. So I would do -1 plus 1, which is 0, and that goes in the first spot. And then I do 2 plus 3, and that goes in the second spot. And then I do 0 plus -1, and that goes in the third spot. And then I do 1 and 2, and that goes in the last spot. I put it in the brackets. Good morning. Okay. All right, this is how your answer is going to look. Now on WebAssign, things get weird when you go to put these in as solutions, okay? When you go to type it in. All right, so this is the format of what it's going to look like on WebAssign. You see the little green arrows? Those little green arrows allow you to add rows or columns in whichever direction they're on. So if your answer was a 2 by 2, you would leave it exactly as that is, and I would type in the answers in that order, okay? If my answer is a 2 by 3, so 2 rows, 3 columns, I'm going to use the green arrow on the right-hand side that's pointing to the right to add a column. So it's not going to be set to the amount of columns you need it to be, okay? If your answer was a 1 by 1, I would reduce both. I'd take it back a column and up a column, and it's going to give you a 1 by 1. Does that make sense? Okay. The best thing about that is if your answer is impossible, in order to get it right, you literally have to put impossible in every single square. So reduce it to one cell, write the word impossible, you're done. Okay, you don't have to write the word impossible in 6 cells. You just have to write it in whatever there. So shrink it down, put impossible in, and you're done. Yeah.
What numbers would you have to get to make it from 2 by 2 to shorter or longer?
Huh?
Like why would it make it longer if it's just like adding?
If it's a 2 by 2, it wouldn't be, but go to the next question. That's a 2 by 3, right? Or 3 by 2 and a 3 by 2. So you would need your answer to be a 3 by 2, but on WebAssign it's going to start as a 2 by 2. So you would have to extend it. So can 2 be done? Yes. 0 plus 3 would be 3. 1 plus 4 would be 5. -2 plus -1 would be -3. 1 plus 2 would be 3. 2 plus 1 would be 3. 3 plus 0 would be 3. Yes. Sure. Easy stuff, right? All right, 3 is a 3 by 1 and a 1 by 3. Can that be done? No, so you would literally write the word impossible. And you would try to reduce it down to one cell, so you only had to do that once. If you don't know how to reduce it, I just showed you, but if you forget, you can copy and paste the word impossible into every cell that's there. Question so far? Yes.
What would multiplication be?
We're not there yet. Okay. There's 2 types of multiplication. The first is easy, which is the scalar multiple, okay? If you have a scalar multiple, it means you have one number that's on the outside. You literally just distribute it to every single term inside there, okay? So that looks like this. Like 4, and this is the other format you're going to see questions on homework, where they give you the matrices in the directions, and then they tell you individually to use something like this. So they'll use notation like that. So 3A means to literally take 3 and distribute it into every term on A. A scalar multiple can be done all the time. So it's not like you have to check the dimensions. So I would do 3 times 2, which is 6. 3 times 2, which is 6. 3 times 4, which is 12. Go to the next row. 3 times -3, which is -9. 3 times 0, which is 0. 3 times -1, which is -3. 3 times 2, which is 6. 3 times 1, which is 3. 3 times 2, which is 6. And you'd enter it in. So your box would have to be a 3 by 3 there. Sorry. Yeah, and it would only be A. So you'd only enter an A for this one. Yep. There'll be some that are compound, but that one is just for A. 5 says -B. What does that mean? change all the signs on B. So you're going to distribute a negative in on B. So it'd be -2, 0, 0, -1, 4, -3, 1, -3, -2. That's the only one that you don't have to show work for on your homework, unless it's an impossible one. Okay, all the rest you're going to at least show the work. Good on that one. Okay, so then negative or 3a minus b means I'm going to first find 3a, and then I'm going to subtract from it b. Now we already found 3a. It's this guy. So I could get 6, 6, 12, -9, 0, -3, 6, 3, 6. And I can do two things with this. I can subtract the original b, which is 2, 0, 0, 1, -4, 3, -1, 3, 2. Or I can add the negative b that we already did. So you can choose to distribute the negative and then add, or you can choose to subtract. It's completely up to you what you do, okay? So if I am going to subtract, it would be 6 minus 2, and that's 4. It would be 6 minus 0, and that's 6. It would be 12 minus 0, and that's 12. And then I go to the next one. It would be -9 minus 1, which is -10. 0 minus -4, which is a +4, because minus a -4 becomes +4. It would be -3 minus 3, which is -6. And then I'd go to the next row. 6 minus -1 minus a negative becomes positive. That's 7. 3 minus 3, 0. And 6 minus 2, 4. God bless you. If you know that a minus negative scenario is like going to throw you off, then I would distribute the negative in and add. So I could have done, like I said, I could have taken that 3a and I could have added it to the negative b. So 6 plus a -2 is 4. 6 plus a 0 is 6. 12 plus 0 is 12. You could have done it that way. So just be careful. I would say the minus negatives is what gets people. Still easy stuff. Yes?